Hi everyone, this is the video for 2.5. Most people I think did it during the 2.5 task, so you really only need to watch this video if you missed class or if you need just a little bit of a refresher. So one thing I want to remind you guys of is that slope is the rate of change, or that pattern that we found back in Module 1. Okay, so we're writing the equations of linear functions, so all of them are going to have a slope or a rate of change. The first thing we're going to talk about is slope-intercept form, which is y equals mx plus b. Now to keep it a little bit more in line with what we're doing, I am going to write it using function notation. So instead of y, I'm going to write it as f of x equals mx plus b. And all I want to point out to you is that m is our slope, or the pattern, the rate of change, and that b is our y-intercept. And y-intercept really just means if you were to make a table, then that b value would be your first y value, and your first x value would be 0. So really, it's a fancy way of saying make a table that starts at 0, and here's your first y value. Okay? So the best time to use slope-intercept form is if you're given a slope, which is m, and a y-intercept, which is b. And again, y-intercept really just means a table that starts at 0. Okay, so let's take a look at this first example here. So we're given a slope of -2, that's our pattern, and we're given this y-intercept of 7. So if we were to make a table really quickly, we would start our table at 0, and our first value would be 7. And then again, this -2 is giving us a pattern. So if we think about how to write this equation based on Module 1, we would say f of x equals 7, which is our first value, plus our pattern, which is -2, and we would multiply by x because the first x value is 0, since our table starts at 0. Well, we can see that that's really similar to that y equals mx plus b that we asked you to write the equation in. It's just written a little backwards. So all we're going to do is take it and rewrite it. We're still going to have f of x, but now we're going to take this -2x and make that come first, and then we're going to do our plus 7. So we still have the same two pieces. Our first value was a +7, and our pattern is a -2. We just wrote it in a different order, but we're not really teaching you anything new here. Point slope form is y equals m times x minus x1 plus y1. Now again, I'm going to write it in function notation. So f of x is m x minus x1 plus y1. And again, we've got m is our slope, so that rate of change or the pattern. And now, instead of having a y-intercept or a table that starts at 0, we're given this point x1, y1. Which means when we make a table, they gave us the first values, x1 and y1. So let's take a look at this example down here. This point 2, -3 is really just saying start your table with that point. So if I make my table, I'm going to start at 2, -3, and I'm going to have a pattern of -1/4. So if we think about what we know from Module 1, that's going to be f of x equals my start value, which is -3, my pattern, which is -1/4, and then I'm going to multiply by x, and since my table starts at +2, this is going to be x minus 2. This is the same thing that we've been doing since Module 1. All we're going to do then is this looks a little different only because of this y value being at the end instead of at the beginning. So all we're going to do is move it. So we're going to write f of x equals -1/4 x minus 2 minus 3. So this is still the same thing. All we did was rearrange the order of it a little bit. but we can still see our pattern is that negative 1 over 4, and we could see then that our table must have started at the point 2, negative 3. So I'm going to jump back up here really quickly just to talk about when this is best to use. So it's best if we are given either a point and a slope, two points, or a table. And the two things that we need in order to write point-slope form are a slope and a point, hence the name, right? So if we look at number 3 right now, we're given two different points, so it doesn't matter which one we pick. But the problem is that we're not actually given a starting value. Or I'm sorry, we're not actually given a slope. So we need to find the slope, which means we're going to make a table, and I've got the point negative 1, negative 3, and I've got the point 2, 3. And we're going to find the slope using change in y over change in x. So to go from negative 3 to positive 3 is plus 6. To go from negative 1 to positive 2 is plus 3, which means if I want to find my slope, which I know is change in y over the change in x, then I'm going to go 6 over 3, which simplifies down to 2. So that means the slope of this line, or the rate of change, is 2. And now I have two separate points that I could pick. Now the way that I made my table, the first point is negative 1, negative 3. So if I were to use that and what I know from Module 1, then I would write f of x equals my starting value, which is negative 3, plus my pattern, which is 2. And since my table starts at negative 1, I have to multiply by x plus 1. So all I'm going to do is rearrange that, and again I'm going to put this first value at the end instead. So it's going to be 2 times x plus 1 minus 3. If we wanted, we could use the other point instead. If we wanted to use the point 2, 3, we could go ahead and write that equation. So that would be f of x equals our pattern, which is 2, times x minus 2, since the table doesn't start at 0, it starts at 2, and then I would do plus 3. So either one of those equations would be okay. It just depends on which point you actually pick. Okay, for this one, we're actually given the equation of a line, and we need to use that in order to graph the line. So hopefully when we look at this, we can see that this number that's in front is just our slope, or the pattern. So m equals negative 2 over 3. And then we should be able to pick out our first point. So since this is x minus 2, it must mean my table is starting at a positive 2, and that positive 2 gives me a value of positive 1. So if we need to rewrite this, we can, by the way. We can put the 1 in front, so it's 1 minus 2 over 3, x minus 2. And that's more what it looked like in Module 1. So we can see the table must have started with a positive 1 and a positive 2, with a pattern of negative 2 over 3. So we're going to use that to actually make our line. So that means we're going to start at the point 2, 1. So 2, 1 is right here. And we're going to use a slope of negative 2 over 3. If it's a negative slope, that means I'm moving down and to the right. So from my starting point, I'm going to move down 2 and to the right 3. And then down 2 and to the right 3. Now I can't go any more that way, but I do want to point out to you guys, we could go the other direction then. So instead of going down and to the right, we could move up and to the left. So I'm going to move up 2 and left 3. Up 2 and left 3. Now you don't have to put all of these points. I just always feel like the more points I can have on my line, the better. All you need to be able to do though is show us that it's a line and then use your ruler to actually draw it through. So you do not have to have all of those points, but you have to have enough to be able to show us that you know how to use the slope and that you know where it started. When you draw your line, make sure you use your ruler and make sure you put arrows to show that it does go on, okay? Now number 5 is actually the opposite. Number 5 is giving you this graph and asking you to write the equation. Well, this is something that you guys have been doing since Module 1 also. So we're going to pick 2 points on here and we're just going to make a table like we've done in the past. So let's see. This point is the point 0, 2. This is the point 3, 0. And now we can go ahead and find the slope, right? If we're given a graph, then we know that the slope is going to be the rise over the run. So I'm going to go down 2, so it's a negative 2, and I'm going to go over 3, so that's a positive 3. So my slope is negative 2 over 3. You could also, if you want, use your table and do change in y over change in x. We're still going to end up getting the same slope. So when I look at this, I can see that this value right here, since it's starting at 0, it actually makes it a little bit easier to write my equation since that's the y-intercept. So I'm going to use f of x equals my starting value, which is 2, and then I need my pattern, which is minus 2 over 3, and I'm going to multiply by x because my table starts at 0. So again, I am going to rearrange it so that it is actually in slope-intercept form. So it's negative 2 over 3x plus 2. So all I did was flip-flop these two terms and write my equation. So we chose slope-intercept form, and we did that because we were able to make our table start at 0, 0. Or at 0, 2, excuse me, not 0, 0. The table started at 0, 2, which is the y-intercept. And then we were able to use rise over run to find the slope. To find the slope. Now if we wanted, we could pick the point 3, 0 and do point slope form instead. All right, it's just a matter of what's the easiest and what's the quickest. We have one more example to talk through here. So determine whether the following equations are equivalent. So what I want to point out to you is that equivalent means, are they the same? Do they represent the same linear function? And we're going to show our work to justify our answer. So if we take a look at these two equations, we can see this one here can't be simplified at all. It says y equals negative 3x plus 2. There's nothing I can do to actually simplify that. So I'm going to have to just leave it alone. The other one, however, y equals negative 3x, or sorry, negative 3x minus 3 minus 7, that we can actually do something with. So if we see parentheses, we have to be able to get rid of them. And since we can't actually simplify what's inside the parentheses, the way to get rid of that is to distribute what's in front. So we're going to take that negative 3 and we are going to distribute it inside the parentheses. So when I say distribute, it means that we're using the distributive property. So we're taking this negative 3 and we're going to give it to the x, and we're going to take this negative 3 and we're going to give it to this negative 3. And the operation that we're going to use is we're going to multiply. So this y is just going to come down, and I'm going to do negative 3 times x, which is just negative 3x. Then I'm going to do negative 3 times negative 3, which is a positive 9. And then this positive 7 is just going to come down. All right, so what I did was I distributed. I multiplied this number in front by the two numbers, or two values, excuse me, that are inside the parentheses. So that's where this negative 3x plus 9 came from. And this plus 7 is just tagging along. Well, now when I look at this, I can see that both of these are just plain numbers. Those are constants that I can actually add together. So now I'm going to do what we call combine like terms. Which really just means I'm going to add those together because I can. I know what 9 plus 7 is. I can use my calculator. So I can get y equals negative 3x plus 16. And now there's nothing else that I can do. So now this is my other equation. Oops, except that I copied the equation wrong. This is a minus 7, which means this is negative 3x plus 2. If I use my calculator, I know that 9 minus 7 is 2. I'm so sorry about that. Hopefully you caught my mistake before I did. So we get the equation is negative 3x plus 2. And if we look at the original equation we had, those end up being the same. We're able to make them match, which means yes, these are equivalent. So we were able to distribute and combine like terms to show that these two equations, although they don't look the same, they are actually the same. So we're going to do tons of practice in class with distributing and combining like terms. If you have questions, please make sure you talk to your Math 1 teacher and get them answered. Thanks for watching.